Welcome to Maths for E channel, a past question on differentiation from Oxford and Cambridge A-level past paper. The equation of a curve is y cubed minus xy plus 4 root x equal 4. Find the gradient of the curve at each of the points where y equal 1. The equation of the curve is given y cubed minus xy plus 4 root x equal 4. We need to find the gradient. Therefore, a gradient of a curve is dy over dx. So differentiate with respect to x we need to do. So y cubed, differentiate with respect to x. First, differentiate with respect to y. So y cubed differentiate with respect to y is 3y squared, and y differentiate with respect to x, dy over dx. So 3y squared dy over dx minus is a product minus x time differentiation of y is dy over dx with respect to x minus then y with the x differentiation of x with respect to x is 1. So minus 1 plus 2 over root 1 over root 2 times 1 over root x equals 0. How this comes up? So 4 root x, differentiation of root x normally is 1 over 2 root x. You can work it out as our standard. You can write it straight away. So 2 common, so 2. That's how this comes up. So 2 times 1 over root x equal differentiation of constant is 0. So that is, yeah. So now dy over dx common inside the bracket 3y squared minus x, and take the rest to the other side. Minus y is plus y, become plus y minus 2 over root x. Then further simplification, dy over dx, simply 1 over 3y squared minus cross multiplication, 1 over 3y squared minus x times y minus 2 over root x. The gradient of the curve is dy over dx. We talked about it, so that's how we actually differentiate. So dy over dx, just we have found now dy over dx when y equal 1. So I see what it is. So I substitute y equal 1. So 1 over 3, y squared is 1, 3 minus x, y is 1, so 1 minus 2 over root x. So now dy over dx, the gradient of the curve at y equal 1 in terms of x. We don't know what the x are, 1 value, 2 value, more than 2 values, we don't know. Let's see, we can find it. So y cube, we can find the x coordinates or x values for y equal 1, substitute in that given equation. So y cube minus xy plus 4 root x equal 4. So y equal 1, simply substitute 1 minus x times 1 is x plus 4 root x equal 4. Keep the root to one side and the rest to the other side. So 4 root x, take the x to the other side plus x, take 1 to the other side, 4 minus 1 is 3, so x plus 3. If you could square it both sides, so this we square in that root x to squaring it. So 16x, so 4 times 4 is 4, 16, root x squared is x, so 16x, x plus 3 squared. Simply expand that, 16x equal x squared plus 6x plus 9. So collecting to one side, x squared, and take the 16 to the other side and plus 6. So minus 16x plus 6x is minus 10x plus 9 equals 0. And this quadratic equation in x, see, we can get that factorized. So x squared parallel across, x squared, and the factors of 9 is minus 9, minus 1, in order to get minus 10. So it's x squared minus x minus 1x is minus 10x, minus 9 minus 1 times minus 1 is plus 9. Okay. So the factors are x minus 1, x minus 9. So x minus 1 times x minus 9 equals 0. From that, x equal 1, x equal 9. So 2 value for x, for y equal 1. So we know where the actual dy over dx when y equal 1, we found it, 1 over 3 minus x times 1 minus 2 over root x. X equal 1 first value, dy over dx, and y is 1, of course. So x is 1, y is 1. So the coordinate of the point which we are getting the gradient is 1, 1. So dy over dx, the point 1, 1, the gradient, 3 minus 1 is 2, so 1 over 2, 1 minus 1 over root x. X is, root x, x is 1, therefore just 2, 1 minus 2. From that is minus half. This is m1, first coordinate or gradient, not coordinate, sorry, gradient. And x equal 9, then of course 9 is the x value, y is 1, y is 1, the y value is 1, the coordinate of the point is 9, 1. So dy dx at 9, 1 is 1 over 3 minus 9, 1 minus 2 over root 9, and 1 over minus 6, and 1 minus 2/3. 1 minus 2/3 is 1/3. 1/3 time minus 1 over 6 minus 1 over 18 as m2. So these two, the gradients for y equal 1. One at 1, 1 coordinates, the other one is 9, 1. Thank you. Please subscribe the channel and share these contents with your friends and A-level students, other A-level students. Thank you.